The formulas we have here, the first thing on that sheet are these formulas, again, that we had yesterday. X equals 1 over 4p, parentheses, y minus h, or y minus k squared plus h, and x equals 1 over 4p times y minus k squared plus h. We have the two formulas that we worked with. The focus was h comma k plus p, and the direct is y is equal to k minus p. And our other one was focus is h plus p comma k, and the directrix is x equals h minus p. So we have these two main formulas here, and we worked with them yesterday. Now we're going to keep working with them today and do we'll do 3 examples of graphing, how to get the formula from the graph, and then we'll do a few more with directrix and focus, or directrix and axis symmetry, having the information and finding the equation. So everything we're doing today is finding the equation, writing the equation. Now, when we look at this graph here, they gave us the vertex and focus. When we look at this here, each one of those lines, those dashes, it's going by 2. Our scale is by 2s. Because here I could almost write it in 2, 4, 6, 8, 10. Go in this direction, 2, 4, 6, 8, 10. So our vertex here, we go over 6 and up 2. So it's 6, 2. Our focus is over 10 and up 2, so it's 10, 2. So just from the graph, we can get the focus and vertex. Now we need the equation. Are we dealing with x equals, or are we dealing with y equals? Now with the graph, there's 2 ways we can figure it out. One is, which way is it opening? It's opening to the right, yes? Which one of the 2 equations open to the right? Y equals or x equals? X equals. So that's one way we can see it. The other is looking at the focus and vertex. And we notice between the focus and vertex, the first term, the x value, changes. Focus and vertex, the x value changes. So it's our x equals. So the equation we're working with here is x is equal to 1 over 4p times y minus k squared plus h. This is the equation we're working with. So we need to find the value of h and k and then p. What's the value of h? The value of h is 6, yes? Because that's the value of the vertex. The value of k is 2. Any questions on this here so far? We good with everything so far, yes? So h and k, 6 and 2, really just came from the vertex, because that's h comma k. The vertex is always going to be h comma k. Now the focus tells us the value of p, because our 10 value is equal to p plus h, or h plus p. We can write it either way. I mean, it's the same thing. P plus h and h plus p are the same thing. And we know the value of h is 6. So we plug it in for h. Now we can solve for p. And we would do that by what? Subtracting 6 from both sides. And when we subtract 6 from both sides, we get 4 is equal to p. 4 is equal to p. So what we can do now is we can plug it in. So we're going to have what? 1 over 4 times 4 y minus k. Our k value is p squared plus 6. Now we need to simplify the fraction. I mean, because 1 over 4 times 4 is just 1 over 16 times y minus 2 squared plus 6. And that's our equation there. And that's it. That's all we have to do for this one here. From what we did yesterday? Yeah, from what we did yesterday, it's kind of, we look more at the equation, or we're given 2 points, or we're given the focus and vertex. Here, we just need to find it in the graph.
Okay.
That's the only real difference between having a graph and given the points, is we have to find them. Sometimes it'll be given to us. What the focus is, it'll be written out because it's hard to tell on a graph, but sometimes they'll just be given. We'll just have to find them. Now, when we have it here, we need to be careful between these two. We need to be careful between these two because, let me get a different color. Blue and green. You have to be careful with H and K. Because we have H inside the parentheses. Because all of these are our H value. And for here, K is outside. Yes? But if we look over on the other set of equations, because on one set of equations, H is inside, K is outside. On the other set, K is inside of the equation, and H is on the outside. Okay? So this is another reason you need to pay attention to these here. Because if you're not paying attention and you rewrite, you put H inside, K outside, for this one here, the one we just did, that's not right. That's the wrong equation. So you have to be careful with the placement of it. So let's look at another one here. So we have our vertex and our focus. Now again, this one's going by twos. Kind of like the last one did. It had a scale of 2 for each one. Now our vertex is over at not just positive 2, it's negative 2 on the x and 4 on the y. Negative 2, 4. The focus is at 2, 4. So here, which value changed? The x's or the y's between the focus and vertex? The x's, yes? So we're still dealing with the same equation. X is equal to 1 over 4p times y minus k squared plus h. We're still working with this equation here. Now, so far, we don't know the value of p. What's the value of k? It's 4, yes? Because from our vertex gives us h comma k. The k value is 4. Plus, well, what's h? H is negative 2. So it gave us the value of h and k because that's just from the vertex. Vertex is h comma k. H is negative 2, k is 4. Questions on this here? Now what do we need to find? We need to find the value of p, yes? Well, p shows up in the vertex because 2 is equal to h plus p is equal to h plus p. And we already know the value of h is negative 2, so we have negative 2 plus p. Now what do we need to do to find the value of p? We need to add 2 to both sides, yes. We would add 2 to both sides. to get p by itself. When we add 2 to both sides, we do get p by itself because these cancel. And we find the value of p is 4. We find the value of p is 4. Any questions on how we found the value of p? So now all we need to do is come back up here and plug 4 in. Well, 4 times 4 is 16. And it gives us x equals 1 over 16, parentheses, y minus 4, close parentheses, squared, minus 2. And that's our equation for this graph here. Any questions on anything we've covered thus far? Are we good with all of this here? All right. So I'm going to do one more. We're going to do one with y equals. Because I feel at this point we're getting pretty comfortable with these, yes? So I want to do one with y equals. Well, we did one in first hour with y equals, but because it'd be good to see at least this one here. Because y equals and x equals, either one of these equations, the way we go about finding it doesn't change. The only thing that's really changing is the h and k, how they get put in, yes? Because for y equals this one here, h is inside, k is outside. For the last two we did, k was inside and h was outside. That swap is probably going to get at least one of y'all on the test or that homework assignment we had yesterday. So be paying attention to that when you plug it in. What value goes where? Now here, the focus is what? One and 0.25. So this one here, they gave it to us because the focus would have been right here. You don't have to draw that in. I'm just kind of showing you this is where the focus would be on the graph. Now the vertex is 1, 0. It's this point right here. So what's the value of h? Is 1, yes? The value of k would be 0, yes? Because the vertex is at 1, 0. So the value of h is 1. The value of k would be 0. So the two ways we can know that we're using y equals 1 is because this is going up. Y equals is either going to go up or it's going to go down. When x has a power greater than 1, so we have x squared for these here, it's either going to go up or it's going to go down. When y is squared, it's going to the left or it's going to the right. Left and right would be y squared, up and down is x squared. Now when we look at the focus and vertex, because the first value is the same, 1 and 1, this is talking about y equals. Now what we need to find is the value of p. So 0.25 is equal to k plus p. What's the value of k? 0, isn't it? Well, 0 plus p is the same as just having p. So the value of p is 0.25 for this one here. The value of p is 0.25. Any questions on this here, how we found the value of p, h, or k? this. So we can plug them in. So we get y is equal to 1 over 4 times 0.25, x minus h, so x minus 1 squared plus 0. So the first thing I would do is, you can do this in the calculator, is do 1 over 4 times 0.25. Let me get it highlighted. Type this into the graphing calculator, because the graphing calculator will do this. It'll simplify this for you. It is 1. It works out that this is just 1. Because 4 times 0.25, well, how many? Because 0.25 is almost like a quarter, isn't it? How many quarters in a dollar? 4, so it reduces to 1. So we'd have 1 over 1, which is just 1, and we don't write 1. We don't normally write the number 1, so this actually just simplifies down to just y equals x minus 1 squared. X minus 1 squared. Questions on this here? Any questions on anything we've done so far? We good with graphs? We feel comfortable with these here? Yes? Okay. So even though that we have one like this here where we get ugly fractions, the numbers, even though the numbers are changing and they look ugly and they look like they should be harder, we should have some other method? No. Even though the numbers look harder, 11/4, the processes that we are doing don't change. And that's going to follow through all of Algebra 2, everything we do in here. Just because the numbers look different doesn't mean the processes change. The processes are still going to be the same, even if we have 11/4 as our focus. Even if we have positive numbers or negative numbers, the process doesn't change. Now this here, vertex is 5 comma negative 1, and directrix is negative 27 over 2. Something's wrong with that slide. Does anybody notice what it is? Something's missing. I believe it says equals y on y equals, doesn't it? On y'all's page?
Yeah, y equals.
Now this isn't a problem because I'm going to write it back. Because the vertex h comma k, well, that's the same for either one of our equations, yes? Does the information as it's written on this screen tell me which one of these two it belongs to? No, we don't know what it belongs to. Because without the y equals, without this being y equals this or x equals this, there's no way to know. There's no way to know which one it is because it could be either or. Because this is just h and k, our directrix tells us the value of p that gives us the information that we need to know which way this is going to open. And I will say the directrix, having the directrix and the vertex, is the easier one to identify which equation we're working with. Because with vertex and focus, we had to kind of look at the numbers and see which one changed. Which one's changing, yes? This one here, it says y equals, doesn't it? Looking at the directrix for both of our sets, one of them is y equals k minus p. The other is x equals h minus p, yes? So it literally states one of them is y equals. This is y equals, so it pretty much tells us it's this equation, yes? Y equals, we're using the y equals 1 over 4p times x minus h squared plus k. Because the directrix literally says y equals something, yes? I think that's a little bit easier because it's pretty much telling us it's this one, yes? It's a little bit, I mean, it's slightly easier than the other one. So because of that, it's telling me I'm using y equals 1 over 4p times x minus h squared plus k. The value of h is 5. The value of k is negative 1. We have these two here, yes? What are we missing? The value of p, yes? Now, we were told, because of this equation, the directrix is y equals k minus p, yes? Because that's just the directrix, is k minus p. Now, we know what this is equal to. This directrix is equal to negative 22 over 7. So I'm going to replace the y value with negative 27 over 2. Not 22. Negative 27 over 2. I know the value of k is negative 1 minus p. So I plugged in what I knew. Because I know the directrix should equal negative 27 over 2. Put that on one side. Filled in the value of k. Now we're going to solve. So what's the first thing I need to do to get p by itself? We're going to add 1 to both sides. How many of y'all feel super comfortable with doing negative 27 over 2 plus 1? Probably not. Not too comfortable doing that? That's fine. The calculator that you have right there will do it for you. If you can do it in your head or kind of see what it is in your head, that's great. Because if you could say that this is 25 over 2, negative 25 over 2, awesome. But if not, plug it into the calculator. Plug it into the calculator. There's nothing wrong with double checking your work. Well, since I don't want to know what negative p is, I want to know what the value of positive p is. We're going to multiply both sides or divide both sides by what? Negative 1. Nope. Because really, the reason we're doing that is to change the sign. Because 1 times anything, it doesn't change its value. Because no matter how many times I have a group of 1, it's still just a group of 1. It's just that one value. So really, we can say that we just switched the signs. We changed the signs. Since p is negative, I want to know positive, so I switch it. So I switch the other one. They both became positive. Because multiplication or division of 1 does not change it. It just changed the sign since we're doing negative 1. So we have 25 over 2. So the value of p is 25 over 2. So when I plug this in, I get y is equal to 1 over 4 times 25 over 2 times x minus h is 5 squared minus 1. This right here. If you feel very comfortable with fractions and fractions, go on and simplify, do it by hand. If you do not feel comfortable with these fractions, plug it in. As we saw yesterday, the graphing calculator will leave it in fractional form if you put it in fractional form. Yes? So we can do it that way. If for some reason it's not giving you in fractional form, ask me, especially on the test. I'll come around. Because if you do math, so you have the decimal and do math fraction, FRAC, it should convert it back to a fraction. It might not be a nice fraction, because if it's converting it over, it's not normally a nice fraction. But it'll do this here. It'll do this here. I have no idea where that thing went. Here it is. So when we plug it in, we would get 1 over, well, try not to write in a highlighter, 1 over 50 times x minus 5 squared minus 1. And that's it. That's all we have to do for this here. Any questions on this here? Processes-wise, this is, I think, maybe just a smidget harder than having the vertex in focus, because we had to do we had to multiply by -1 and do a few more steps. but it's not really any harder than when we have the vertex in focus, yes? I mean, it's not overly more difficult. Would y'all agree with that? I mean, most of the stuff we've covered, and again, I know that pretty much anybody you talk to about Algebra 2 says it's one of the hardest math classes you'll take in high school, yes? Has anything we've covered so far really been just insanely difficult? Not too much, right? It's just a lot of little easy steps. Because as long as we get all the steps in the correct order, we're fine. It's pretty easy going from one step to the next. And that's really what I would focus on, especially the more that we get into this. It's just keeping the steps straight, keeping the steps straight. So with your review sheet, I would be making sure you have those steps down. Because again, that's why I let you have them on the test, because you can read back, you can look back at them. Even though they're not the same problem, the steps are always going to be the same no matter what we're doing. Yes? Mm-hmm. I think we're good with vertex and focus, yes? You guys want to look one more at vertex and directrix? Yes? Let's do one more of these. Looking at this here, which equation would we use? X equals or Y equals? Y equals, because it tells us the directrix is Y equals a number. And that's the one that has the directrix as Y equals K minus P. So we're using Y equals 1 over 4P times X minus H squared plus K. Now, I didn't say this or tell this to first hour, but one of the ways I write this when I'm writing these, that I keep H and K straight, which one's which, and this works with pretty much all of the quadratics and stuff that we use in this form. X and H go together. X and H go together. Let's look at the vertex. X is, the H value is in the X spot, yes, for a point? X and H always go together. Y and K go together. They always stick together. So as soon as I do Y equals, well, X and H have to be together. K is on the outside because Y ditched in to go somewhere else, right? X and H are together, Y and K. Inside those parentheses, X, since X is inside the parentheses, H has to be inside the parentheses. If Y is inside the parentheses, K has to be there with them. All right. What is the value of H? It is, K is 9. We still need to find the value of P. We still need to find the value of P. Now for this here, the directrix said Y is equal to K minus P. Where our directrix value is 73 over 8. The K value is 9. What do we need to do next to get P by itself? We need to subtract 9 from both sides. I would plug this into the calculator. The one that we did before with subtraction of 1 from, with our halves, 27 halves, adding 1 to it or subtracting 1 to it, that's not bad because we're talking about 2 and 1, it's simple. This one here, I would plug in. I'd plug it in. I'd plug it in. Because this is a little bit harder to convert because we'd have to convert 9 into whatever it is over 8, which is, I think, 72 over 8, because I did it first hour. Or you can just plug this straight into the calculator. And I think it's 1/8 if I remember correctly. Okay. So again, plugging that in, because I'm not expecting y'all to do fraction subtraction. Subtracting fractions. But we're not quite done. What do we need to do? Divide by -1, yes. because what that'll give us is negative p, or not negative p, it'd be positive, because a negative divided by a negative is positive p is equal to negative 1/8. Any questions on how we found HK or P? Okay. So, negative 1/8. Plug them in. The last step is to plug them in. So we have 1 over 4 times negative 1/8 times x minus h is 8 squared plus 9. Now, as I said earlier, I'd plug that one in. I'd plug that one into the calculator. Because there's always a chance that it's not going to be a fraction. There's always a chance this isn't going to be a fraction. So go on and plug it in and we'll see what it is. And what we get is y is equal to negative 2. Now the calculator will take care of that. They've got it smart enough now that it can do that. It can figure all that stuff out. But that's it. Questions on this here? Questions on any of this here so far? We good with this here? Do we need to see any more of these? So we could still have this and have ugly fractions, but the processes that we do to find those values does not change. It does not change. And that's it. Now there is a homework assignment attached to this here. We can have very ugly fractions. But that's all we're doing for this here.